I'm going to do experiment 29 from the Elementary Science with Vernier manual. It's the What a Drag lab. And in this lab, what we do is investigate different shoes, and in particular their bottoms, the frictional surface between the shoe and, say, the ground, or in this case, we'll use the tabletop. For this lab, we're using the dual range force sensor, and since it's dual range, it has a little setting switch here. We want to make sure this one's on the plus or minus 10 Newton position. And the way this device works is that it measures forces that are applied here to the hook, and you can push it or pull it back and forth, and the computer will measure that device there, or the forces. To interface this with our computer, we're going to use the Go link. And the Go link is a single channel interface that plugs into the USB port of the computer. And to attach the force sensor, we just plug it into the Go link. And the computer software, the Loggerlight software, recognizes the sensor. But because we're doing a lab from the elementary manual, we can go in and open the file for this lab. And so we will go up to Open. And I want to go to Elementary Science, and I want to open experiment 29, What a Drag. So the file's open, and if we look on the bottom of the graph there, it says we have 4 seconds, and on the force axis, the y-axis is force. And but if we notice down in the lower left-hand corner, we notice that the force currently isn't reading 0. And that's because the force sensor reads differently depending on the orientation. And you would hope that it would read 0 if it's sitting in this position. One of the reasons that it's not is that this sensor, depending on the position, can read different readings. And I'm going to be using it in a horizontal position, so I want to make sure that it reads 0 when it's in the horizontal position. So if you'll notice at the top of the screen, there's actually a 0 button. So for certain sensors, this shows up, so it's important for force, so I'll hit 0. And now the sensor reads 0. And now I'm ready to collect some data. So I'll just pick a shoe. Why don't I start with the red one here. To attach the force sensor to the shoe, for this case, I've just run a paper clip around there. Other ones I've put a string, and so that depending on the type of shoe you can have different ways to connect the force sensor. So what I will do is to take the hook on the force sensor and hook it like that to the shoe to be able to pull this. It is important when you're pulling the shoe to make sure that you keep the force sensor parallel to the tabletop. You don't want to pull up, or so you're lifting the shoe. You want to make sure you're just dragging it parallel to the top there. To start collection, I'm actually going to use the space bar. The software is set so that you can actually hit the space bar to make it collect as opposed to hitting the collect button. It's a little harder to be able to do if you're doing it by yourself here. Now, it's important with this lab that the students actually start dragging the shoe right before they hit the collect, because they want to make sure that there's not a lot of 0 in there, so there's no force, because they're going to come in and get the average force, and so we don't want to have any 0 force in there. So I'm going to come in, hit collect, I drag it along, and there we go. So there's one run, and in the lab there's a table, and they can go down and describe the shoe. They'll write down the weight of the shoe, which I've already done, and then they write down the amount of force that it was required to pull the shoe along, so the average force. So we'll actually do the average there in just a minute. So I've done the first run, and so I'm going to store that one. And then next, I'm going to use this shoe, and I very deliberately had this one attached with a string, again, just to show you there are different ways that you can attach the force sensor to the shoe. And so, like the last one, I have to attach the sensor, and then I'm going to start pulling. I hit there, and there we go. Okay, so let me store that run. And then I'm going to do this shoe. For this one, it turns out that I can actually put the hook from the force sensor just right there. So I didn't even bother to attach a string or a paper clip or anything like that. Now I may have to adjust my hook there a little bit. And I start pulling. Hit collect. There we go. Okay. Oh, those are 3 really nice runs. And so I'm going to store that one. Then I'm going to do an auto scale. Oh, there we go. So the green line at the top is the river shoe, the pink shoe. The middle line is the black shoe, and the red line is the red shoe. And so we see a different amount of force required to pull the shoe. And now we're ready to do the stats. We want to find the mean force that we put on the shoe as they were dragging. So let me go up to stats. And I want to do run 1, run 2, and then the latest run. So I'm going to do all 3 of them together. And I will say OK. And so now I can separate these a little bit. And so the upper one, the mean is 2.08 newtons. The black shoe is 1.14 newtons, and for the red shoe is 0.7 newtons. So it required quite a bit less force to pull the red shoe along the tabletop. So this is a great lab to have students investigate things in their real world. They've all experienced different shoes, and so maybe they know that one shoe is slicker than the other. And with this lab, they actually have an opportunity to quantify the difference in some of that friction. And this lab naturally leads to modifications, and so you can go in and do that. And or you can even do this, where you can go and do another lab that's related to it. We have our sole purpose lab. They actually take a temperature sensor and they can rub it on the bottom of the shoe, and if they do it with a slick-soled shoe, they don't get as much friction, it doesn't heat up as much. So it's just a natural connection with that. And so, you know, my experience in labs like this is that students naturally want to try other surfaces. You know, try some ice, try it in the dirt, try it on the gym floor. And so you can really open it up and let them, you know, really get into an inquiry about friction. If you want to make changes permanently to the lab, we have word processing files at the end of each of the books. And you can go in there and modify that so that it matches exactly how you want it to be.